Hello, this is a video depicting my final project for Intro to Machine Learning. I created a decision tree to see the potential values, features that would be linked together um, for COVID-19 in countries. So it has a lot of country info and information about COVID itself in those countries. First things first, I'll run you through the um the data set itself and what all the values mean. First is the region and the country. These are the alpha codes. The population of the country. The number of corona detection tests made per day as of 3/24/2020. Tests per population as for 3/24/2020. The density, the amount of citizens per square meter. The median age, the urban population, percentage of people who live in urban locations. Quarantine, the initial date of the quarantine policy in the country. The initial date of school closure policies in the country. The initial date of public places restrictions in the country. The gathering limit, maximum number of people allowed to gather in that country. The initial date of those restrictions. The initial date of avoiding non-essential house leavings. The amount of hospital beds per 1,000 people. The percentage of smokers within the population. That's the part of the information because corona is a virus dealing with the lungs. The amount of males per female at birth as of 2020. The amount of males per female between the ages of 0 and 14. The amount of males per female in the age group of 14 to 25. So this helps show if there's anything to do with sexes or age. Same thing for the age group of 26 to 54 and 55 to 64 and 65 up. Just literally the amount of males per female. The death rate of lung diseases per 100,000 people. Once again, dealing with lungs. The death rate from diseases from 1,000 people for females. For male, the GDP for the country as of 2019. Health expenses in international USD, inflation taken into account apparently. The health expenses divided by the population times that, not as percentages of GDP. Average rate of fertility or amount of children per woman. The average temp in the country. The average humidity in the country. The first date that the virus was detected. The total number of confirmed cases in the country. Total active cases as of 3/30/2020. The total active cases as of 3/31/2020. Total active cases of 4/1/2020. Total active cases of 4/2/2020. And total active cases of 4/3/2020. Same thing for new cases for these dates. Total number of deaths in that country. And total number new deaths as of these dates, like the others. A total number of recovered from the virus in that country. The amount of critical patients within these dates. Confirmed cases per million population. and confirm deaths per million population. It had a lot of information, but I needed to explain what each of those was. And then let's go to the decision tree that I made. I ended up using Weka due to programming issues. The best result I got and was able to display a tree was with random tree with a cross validation of 10 folds. This is just the list of all the things I had just explained. What this model is hopefully meant to do is show what values of these does the model think are important for predicting the deaths. Like which ones does it think actually are important in predicting these? In this case, it thinks the amount of new deaths on this date are important. It believes the male to female ratio of 0 to 14 is important. It believes where the first date of the, or what the date was the first case in that country. What is that's important. And then it tries to predict the number in millions in a country for that. Those were the first things it split off of. So the model's not super accurate because I had a bit more of a limited data set because not as many things, not as much information is publicly available. Some countries are keeping things a bit more under wraps. Like there are countries that are not part of the list that I have part of. But other things it split off of that it finds important. The gathering limit. Apparently that it believes that is an important aspect. Like the amount of people who are allowed to gather in one place. It believes that is an important aspect of the model, or important aspect to predict the number of deaths that could happen. Another, let's see, what other values does it predict? The median age, apparently age could be, like, the average age could be a thing that could be of importance. The amount of active, it makes sense that that would be important to, or how many deaths are going to, that possibly might happen. The GDP and age and sex, or things that it divided off of too, including density. New deaths are kind of obvious for a splitting point. Very long model. Date of quarantine, very important. And the model seems to back that up. When they started quarantine is a factor. The density, population density, that also can be important because I'm no expert, but that could potentially mean like the amount of people who live near to each other could have a thing to do with this. Humidity might potentially, I guess, because it is an airborne thing. I'm not sure of that one. Urban population, I guess that could be important too. It splits off that. There are many values that it didn't take into account of the 60 or so that it was given. So, number of tests is an important aspect. While this is not perfect, it does like narrow down some of the areas the model thinks are worth splitting off of and using to predict the number of deaths. This could be used potentially just to see what things of this could have have an impact at least on the number of deaths. What made it worse in a country? What made it better in a country? That's what this was aiming for. It's not a perfect solution. There's probably better models, but with the information I had, I think this worked out pretty well. It shows areas that it believes are important, like the first case or the density and stuff like that. If I had more information, this could potentially be used. I would believe it could be used by like medical institutions to find out, or government, or anyone who wanted to know what makes the spread of the virus better or worse in a country, because plans could be made off that potentially. Um, but yeah, it narrows down the 60 or so values into like maybe 10. It's not a perfect solution. There's probably ones that it missed, but it does give you a general idea. And it can be used to predict other things like let's see. Like number of cases. Try this. What does it split off this then? Yeah. How many were critical? What is the urban population? Once again, the first case. That is important. Yeah, suddenly the female lung is a factor, unlike the other one. First case pops up a lot. So that is probably a very important number. Population. Once again, tests, the number of active, lung disease, density. There you can see there's crisscross between these two. But some are like new that weren't used in the other one. It's interesting that you can make this kind of comparison in this data set. While once again the data set's not perfect, and there is error in this, but it does help you get a general idea of what it thinks without knowing anything about COVID are important aspects. A non-biased view, it might be a bit biased if the error is high enough, but a non-human view of what is potentially important information for this. That is my project. I hope people find this interesting as much as I did when I was doing this. I learned a lot about this when I was researching this. Machine learning has been used in a lot of different ways for dealing with COVID, predicting problem areas, like predicting where might the spread be worse in areas, or what is the correlation between symptoms, things like that. There's many different ways machine learning has been used against COVID. Sadly, not all this information is public because some countries do not share it as openly as others, so it's harder to gather a large data set of everything. But it's something. Well, I hope everyone was interested in this as much as I was, and I hope you learned something. I sure did. Thank you for watching.